Next example comes out of section 3.3, the factor theorem. We're asked to divide x cubed plus 4x squared plus x minus 6 by x minus 1 and then completely factor the result. Now that won't make sense until we do the first little bit, so let's do the division. Just for practice, we can do it either by long division or synthetic, so synthetic's a little faster. We'll set up our coefficients, 1, positive 4, positive 1, minus 6, dividing minus 1, bring down the 1, negative 1 times 1 is negative 1, subtract, I get 5, negative 1 times 5 is negative 5, I subtract, I get 6, negative 1 times 6 is negative 6, I subtract, and I get 0, which is good news when you're doing division, because if the remainder is 0, what it means is that this polynomial that I got as a result here is the quotient x squared plus 5x plus 6 is equal to the division x cubed plus 4x squared plus x minus 6 divided by x minus 1. No remainder, so I don't need to write plus 0 or anything like that. So what that means is that x minus 1 times x squared plus 5x plus 6 is equal to our big fat polynomial x cubed plus 4x squared plus x minus 6. Now when I say completely factor, it means that this x squared plus 5x plus 6 term factors, and it's relatively simple one to factor in that I'm looking for two numbers that multiply together to give me 6 and add together to give me 5, so x plus 2 times x plus 3. What we've done now for the first time is completely factored a cubic polynomial that we didn't have the ability to factor before. In all our math 10 or 20 skills, we weren't able to say, oh, how do we factor x cubed plus 4x squared plus x minus 6? But now that we have the ability to divide, we discovered that this was a factor because the remainder was 0. It allowed us to actually completely factor this polynomial. Now in the next examples, we'll talk about where do you start if you're just asked to completely factor something. What do you decide to divide by? In this case, we were told to divide by x minus 1. That won't always be the case.